Any questions? Not having my glasses fog up. I got spoiled over the past couple of weeks by not having them fog up, so get to relive those glory days of the pandemic. All right, so we last left off with, I believe, projectile motion. We did, how far did we get? We just set it up or we actually solved it?
You just set it up.
Okay. Oh, that's right, we did it for the object being shot and dropped at the same time. All right, so let's just run through a quick one of those. Keep it horizontal. Let's give this instead, so let's make this 40 meters. Make that H. Are you okay with this, Ollie? You want up to be positive?
No.
Are you good?
Yes.
No. Anybody want up to be positive? We got a voice of one. Anyone want it down? It's 1 against 1. So we're gonna leave it like that. So V initial is equal to some speed in the I-hat direction. So this is just basically indicating that it's horizontal. Let's make this Venus. That should be enough. So how tall is the cliff? It's the exact same process that we went through before. It's just, we have a different unknown. But we'll set up, we have our I hat and our J hat. We have our quantities of displacement, initial velocity, final velocity, acceleration, and time. So what do we know?
We know everything.
Well, true. What's given in the problem? How about that? Just to narrow it down a little bit.
J hat, is that horizontal?
Pardon?
J hat the horizontal?
No, I hat's the horizontal.
I had 40.
Define I hat, J hat.
Ah, okay.
Okay.
And travel 40 meters distance.
Okay. So this is 40 meters.
That's about it. No. No. Well. Do we know,
Acceleration is 9.8 for the J-hat.
Ooh. Was it Micah? We are. What is the acceleration of gravity on Venus?
Oh, it's Venus, never mind. I didn't see that.
Yeah, watch out for that, because that's the kind of thing I do on a test where I throw you onto a different place.
awesome sauce? Landed on Venus in physics.
So, well, not your phone to look it up? No. Yes, you are.
I'm going to throw a guess, 6.2. See how
I
close.
think it's like 8.9, but
Awesome.
you just have to type in little g Venus in search, and it should pop up.
Acceleration due to gravity on Venus is 8.87 milliseconds squared.
Try that one again.
Oh, meters. Meters per second squared.
Yeah, there we go. All right. So 8.87 meters per second squared. Positive or negative?
Positive,
Why?
because we've determined it to be so.
Okay, yes, for both those reasons. All right, what else do we know? We know at least one other thing.
Would it be the final velocity? Is it zero once
Once it hits,
yeah.
even though the language is it goes 40 meters, we're really looking at the problem for just before it touches the ground.
Oh, okay.
Because once it touches the ground, acceleration is not constant anymore, and we can't use those equations.
Is I hat acceleration 0?
It is. We know one other thing.
Do we know the time? I don't think so.
No.
So, initial velocity for J is 0 meters per second.
All right. We know that. We also know that these two will be the same. Since there is no acceleration horizontally, the velocity won't change horizontally.
What? You're right, no, so if there's no acceleration, okay.
And that's H, that's what we're trying to find. It's possible we don't have enough information, but we'll find out. I think we do. So now what?
We use some cake.
Absolutely. Let's just write down the equations. What are the 4 cake equations? Now, it'd be really great if we could do some of these without looking them up.
I just have a question real quick.
Oh, yes, Sarah.
About, okay, so you have the velocity of I, but what is the velocity underneath it? Because to me, it looks like a T, but it could be an F.
Where are you looking? Here?
Yes.
That's an I.
Oh, yes. And then the one below it.
That's an F.
Okay. I didn't know if it could be a T, an F, or if it was.
F for final.
Okay.
I guess T for terminal.
Okay.
Right.
Terminal cancel. It's the first thing I think of. The terminal.
There you go. Associated physics with death.
Yeah. Smart. Okay.
All right. Want to have your thoughts? And by the way, I have no problem if you want to mock cancer. My mom died from it, so it's how I deal with it, by mocking it. So,
Anyway, so.
yeah, on happier notes.
Change in position equals, final velocity minus initial velocity. No, initial velocity plus final velocity. And all over, 2 times, time.
All right, one down. Oh, you're gonna make Ibrahim do all of it? I think it's on you again. See, there's another one.
Initial, or displacement, right, is equal to initial velocity times time plus half acceleration time squared.
All right, so I got the 2 displacement ones. Tristan?
I can say anything. I can say anyone.
Yeah.
Final velocity equals initial velocity plus acceleration
You said acceleration time?
times time.
Time, okay. All right, 1 to go. Are we going to put in one more time? Micah says yes. All right, I think Carolyn did.
Acceleration equals change in, or sorry, so final velocity minus initial velocity over time.
Yeah, that's just basically that. These two equations are the same.
Oh,
This comes from the definition of acceleration, which we then just manipulated into that. So that does not count as a different one. It's a different form of one of the ones we have already. And for those who had physics, it's the conservation of energy one. Except disguised.
are you looking for the one, the scalar one?
Yep.
So, V without the vector sign was final squared.
So speed squared, final speed squared.
Final speed squared equals, initial speed squared plus 2a, dot, displacement.
Alright. Although these equations would be given to you on a quiz or a test, it is still good to know them. Especially if, even though they are given on quizzes or tests, a higher percentage than you might expect, write the equations down wrong. Alright, so. Which equation would we use? What are we trying to find? Sorry?
No.
Vertical. We're trying to find vertical displacement. Sorry. As an intermediate step, I mean, which equation do we use first?
Final velocity?
This one right here?
Yeah.
For horizontal or vertical?
For, oh wait, mean times, oh no, yeah, for horizontal.
All right.
Oh, you want, okay, so, final velocity equals,
So this is I hat equation.
oh, let's do J hat. I'm becoming a
All right. If we finish up the I hat, that's what we end up with, plus 0.
yeah,
All right. So J hat.
is final, yeah, final velocity equals, 0 plus 8.87 times time.
Now, because we're going to have two VFs here, because we have vertical and horizontal, let's do something like, we'll call that A. Just so that we can distinguish between the two. So I'm going to call this A. And I will call this one B. Just in case. All right. So we have one equation, two unknowns. How do you solve one equation, two unknowns?
You find the unknown,
Except there's two of them.
then you throw one of them.
Yeah, please don't.
Okay.
Can you use simultaneous equations?
Yeah, we need another equation. Which one?
Velocity final squared.
Okay, so if we do, a squared is equal to 0 squared plus 2, 8.87 times h.
Still have two unknowns.
Oh, now we're up to 3 unknowns. Two equations, 3 unknowns. This is also a J hat equation.
Ooh, I have an idea.
Yep.
No. No, never mind.
I will mind sometimes. I will ignore your request for me to never mind.
Well, see, you've done, don't.
Anyone? Or we could just hear Ibrahim go through his path to madness.
Wait,
Oh, yes?
So can we use the acceleration equal, or like the,
One of these,
yeah, have we already used?
that's what we did here.
Yep, running into madness.
All right, now you're stuck in a situation, oh, Skylar,
Never mind.
again, I will ignore the never.
Can we use the displacement?
Say it again?
Displacement is equal to V initial time plus 1/2.
All right, so you plug it into this one,
Yeah.
well, the J hat or vertical or horizontal?
The J hat.
All right, so if we do the J hat equation on that one, we have H is equal to 0 plus 1/2 8.87 times squared. All right, we now have three equations, three unknowns. This is solvable. How do you solve it?
I think we need a new equation.
What equation? Well, we have only one that we haven't used yet. You wanna plug into that one and just see what happens?
Nah, I think we need to find like, a new equation.
Oh, derive something completely new.
Yeah. Not the way.
There is a fifth equation, but it's really not gonna help a whole lot.
Okay.
The fifth equation looks a lot like this one, except that's VF and that's negative.
Awesome sauce. Anywho, so you said this is, wait, can't we plug in, if H is equal to the 0 plus half of 8.87 t squared, can you plug in the fourth equation into the third equation?
Yep. All right, so that is 4.435. So this, if we combine those two, I have A squared is equal to 2 times 8.87 times 4.435 t squared. Now what?
Ooh, can you square root the whole thing? Or square
Yes.
root both sides?
Yes, I can.
Can you? Like in,
Well, without a calculator, it'd be difficult, but
Can you put the A, since that's A squared, could you put that equation and square root it? Oh, man, not square root it, but square it? That
oh,
A-
square that one?
Yes.
Oh, we could do that too.
So-
So either take the square root of this one, solve for A, plug into here, or square this one, and then you'll have a times squared. Because we can then plug in for A squared. Either way, does not matter.
let's square it.
So if we square that one, we get 8.87 squared t squared equals A squared, which is equal to that. What we're gonna end up with though, however, now there is a problem there. Because we're, ultimately, if we do it that way, we're gonna come out with 1 equals 1, which is a true statement, but not particularly helpful.
The struggles of an everyday physicist.
So, because these are not independent of each other, we need to take a different approach. If we look at the first one, we might still run into the same issue there. So if we, the first equation we plug into, we get H is equal to 0 plus A over 2 times T. So,
Okay.
they're not independent. So this is not the right tack.
Whatever do we do?
We still have information from the other side. All right, so this is, I'm going to remove that one for right now. All right, so this is all the J hat stuff. If we plug the I hat stuff in there, let's see if we can come up with something there. And so the general approach is you just plug in until you find something. And I might have left off some piece of information. So if we plug the IHAT information in, into the first one, we get 40 is equal to VT. Plug into the second one, we get 40 is equal to VT. Ooh, that's better. If we plug into the third one, we get V final equals V. And we plug into the fourth one, we end up with V final squared is equal to V squared plus 0. Okay, so that gets us nowhere. Did I give you an impossible problem here?
I have a question.
I did give you an impossible problem. All right.
So, I
Yes.
just have a question though. So, when you have your J hat for the first equation up there,
Uh-huh.
so you said the final velocity equals that equation, which equals A.
Right.
Over there you have final velocity for J, which is A. So how did you get the A over here?
I did, all right, because we had two different VFs, I just used the letter A to represent the
So-
vertical part.
That A will represent the VF.
Yeah.
So would you square that A,
You could square that A.
or would you just make that equation equal put it up for the other equation at the top, and then it would be that equation equals that? Would that still equal 1 equals 1?
Yeah, it still would. All right, so here's the problem. I have a marker that ends up going, or I throw something and it goes 40 meters from the base of the cliff. If this is really tall, and I projected it out, I don't have to throw it very far because it's gonna be in the air so much time, it's gonna get enough horizontal displacement. If it's really short, then I have to throw it really hard, but I can still make it 40 meters. There's more than one scenario where I can go 40 meters and have so how far it goes depends on how fast I'm going, and upon that, those two things will vary, so. And this is a lesson of why I should actually work through problems before I give them out on tests or quizzes especially. So let's add a piece of information in here. Let's make this